KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
In continuation to the last class, in this class, we start to discuss with theorems of perpendicular and parallel axis. Okay. But in this class, we will concentrate on theorem of perpendicular axis and the moment of inertia values, right? That is what moment of inertia values for some regular shaped bodies about specific axis. Okay, right. So first we are going to concentrate on theorem of perpendicular axis, right? Theorem of perpendicular axis. Okay, right. See here, you know what is moment of inertia we discussed in our previous class, right? So in our previous class we concentrated on what is moment of inertia and what is radius of gyration, right? And moment of inertia is a scalar or vector, and what are the dimensional formulas of moment of inertia, right? And how to calculate moment of inertia, right? But it is not the same for all. Even for one particular body, it changes when you are going to change the axis of rotation on which a body is going to rotate. Okay, right. And if you are going to see once again, you know, generally the moment of inertia, right? Generally the moment of inertia is analogous of mass in translational motion, right? So moment of inertia in rotational motion and mass in linear motion or translatory motion, right? So what is the role of mass and what is the role of inertia in case of translatory motion? Here the moment of inertia play the same role, right? So as simple as such, the moment of inertia is resistance to the rotational motion of a body. Resistance to the rotational motion of a body. And you know, in case of translatory motion, as I told you already, mass is the measure of inertia. Mass is the measure of inertia, right? So here, you know, in case of moment of inertia, not only mass and the distance of particle from axis of rotation also important. Okay, that's why generally I is equal to mr square. So that is what mass of the body and square of the distance of a body from axis of rotation. But it is not fixed, I can't say this is like permanent, because you know I already told you in the same class, the moment of inertia value changes even for one body when you are changing the axis of rotation, right? So the position of a body from axis of rotation and distribution of mass and mass itself like this, so many factors are here which determines the moment of inertia, right? The moment of inertia. Okay, and you know what is the rotational kinetic energy? That is what of I omega square. So in case of translational motion, translational kinetic energy is of mv square, but in case of rotational motion, that is what rotational kinetic energy is 1/2 omega square. 1/2 omega square. Okay, so that's why it is analogous. So the rotational kinetic energy is the analog of that is what kinetic energy in translatory motion. Kinetic energy in translatory motion. Okay, that's what I told you. There it is half mv square, it is half I omega square, right? I is nothing but moment of inertia, and omega is the angular velocity. Omega is the angular velocity. Okay, right. So this information, whatever I am saying now, that we discussed in our previous class. Okay, but in continuation to that, here we are going to discuss theorem of perpendicular axis, right? So there is one more important theorem. So these two theorems are very, very important, not only for board point of view, for competitive exams point of view also. These two theorems are very, very important. And now in this class, our focus is to discuss about theorem of perpendicular axis. Theorem of perpendicular axis. Okay. So, and as I told you, on what factors the moment of inertia depends. That is very important. You know, the mass of the body and shape and size of the body and distribution of mass about the axis of rotation and the position and orientation of axis of rotation. I will repeat once again. So this line is very, very important when we are going to discuss, before going to discuss theorem of perpendicular axis. Okay. So what I am saying is, you know, the moment of inertia of a rigid body depends on the mass of the body, comma, its shape and size. I mean shape and size of the body, distribution of mass about the axis of rotation, and the position and orientation of axis of rotation, and the position and orientation of the axis of rotation. These are the factors which determines the moment of inertia of a body, right? We have different bodies, you know, that is what a circular ring, right? And you know, thin rod, circular disc, hollow cylinder, solid cylinder, hollow sphere, solid sphere, right? So we have so many regular shaped bodies, right? That's why similarly you can go for irregular bodies also. Okay, that's why here, you know, when we are going to calculate moment of inertia, for example, regarding one body, suppose for example the axis which is passing through its center perpendicular to its plate, and you know the axis which is passing through any diameter of the object. So like that we have different axes of rotation for one particular rigid body. By knowing the moment of inertia with respect to one axis of rotation, is it possible to determine the moment of inertia with respect to another axis of rotation? That is the important discussion, that is the benefit we are going to get through the discussion of perpendicular axis theorem and then parallel axis theorem. Okay, right. Now you see here, this theorem, that is what perpendicular axis theorem, right? The perpendicular axis theorem is just like application in working out the moments of inertia of some regular shaped bodies. Okay, right. That is what the benefit what we are getting in our daily life. Next, this theorem, that is what perpendicular axis theorem, is applicable to bodies which are planar. Planar means like, for example, you know, that is what lunch plate, right? So when we are going lunch, we are taking one plate, no? So that is what is a planar body. Otherwise you take the board, so this is also planar the body, right? So like that, this theorem is applicable to bodies which are planar. Okay. In practice, this means the theorem applies to flat bodies. Flat, I hope you are able to imagine flat bodies whose thickness is very small compared to other dimensions like length, breadth and radius, right, and area of cross section. You know, generally if it is available in the shape of, if the shape is like a circle, means area of cross section will become generally pi r square. So generally in case of rod, because rod is not a flat body, I don't want to take it as example, but just to describe area of cross section, I am taking a rod. You know, rod is in the shape of circle, no? So if you take area of cross section, it will be pi r square, right? But here rod is not the matter, because he is saying very clear, that is what this theorem applies to flat bodies whose thickness is very small compared to their other dimensions like length, breadth and radius or radius. Okay, so that is what, like a lunch plate, right? So where we are going to get lunch, and the board like material, right? And any other, whatever it may be, like top of the desk. Okay, so for those bodies you can apply this perpendicular axis theorem. Next, see here, the moment of inertia, right? Here he is giving the statement. So this is the statement of perpendicular axis theorem. So you please be concentrated here. The moment of inertia of a planar body, in the bracket you can write it as lamina. The moment of inertia of a planar body about an axis perpendicular to its plane is equal to the sum of its moment of inertia about two perpendicular axes concurrent with perpendicular axis and lying in the plane of the body. Right? So here, to understand this, I request you to imagine the lunch plate. Otherwise, you just imagine exam pad, right? You know, if you keep that horizontally, you can understand what is x-axis, what is y-axis and what is z-axis, right? I hope you are able to imagine what is x-axis, what is y-axis, what is z-axis by keeping exam pad in horizontal position, right? You know, if you know the moment of inertia, about moment of inertia of the exam pad about an x-axis, right? About an x-axis and about an y-axis, you need not to determine moment of inertia about z-axis, because according to perpendicular axis theorem, he is saying that Iz is equal to Ix plus Iy. Iz is equal to Ix plus Iy, right? You can see this picture. See here, right? You can see this picture. Okay. See, this is what z-axis, it is what y-axis, it is what x-axis. What is the Cartesian coordinate system? You know, right? So that's why three axes are mutually perpendicular to each other, and you know, distance of point from y-axis, from origin and from x-axis, right? From z-axis. So everything we had here, and it is the center point O, right? And first, if you know the moment of inertia about an x-axis and y-axis, the moment of inertia about z-axis need not to calculate. That is the benefit we are getting from perpendicular axis theorem. So what the perpendicular axis theorem is saying, as simple as such, in case of planar bodies, moment of inertia of a body about z-axis, which is perpendicular to the plane and passing through its center, is the sum of moment of inertia about an x-axis and about an y-axis. So Ix is the moment of inertia of this planar body about x-axis. Iy is the moment of inertia of the planar body about y-axis, right? So if you know the moment of inertia about x and y axis respectively, and if you add, that will be equal to the moment of inertia of the planar body about z-axis, right? So the statement is very important. Nothing is here to go in deep. The one and only thing is, what is perpendicular axis theorem and what is the benefit we are getting in our daily life from perpendicular axis theorem. That is the only thing. Okay, right. Now based on this, we are going to discuss one example here itself. What is the moment of inertia of a disc about one of its diameter, right? So these are all diameters, you know, that is what x, y, z, right? So these are all diameter. So here, what is the moment of inertia of a disc about one of its diameter, right? That is the question. That is the question, right? So we have to answer for this question, right? See this picture. This picture belongs to our example problem, right? We assume the moment of inertia of the disc. We assume the moment of inertia of the disk about an axis perpendicular to it, about an axis perpendicular to it, and through its center to be known as mr square by 2, mr square by 2, where m is the mass of the disk and r is the radius of the disk. That's you know, right? So the moment of inertia of the disk about an axis perpendicular to it and through its center I is equal to mr square by 2, right? Mr square by 2. See here. So m is the mass of the disk and r is the radius of the disk. Okay, right. The disk can be considered to be planar body. Disk can be considered to be planar body, and hence the theorem of perpendicular axis. Hence the theorem of perpendicular axis is applicable to it. Okay, as shown in the figure here, that is what we can say. As shown in the figure, we take the three concurrent axes through the center of the disk O as x, y and z axis. X and y axis lie in the plane of the disk, right? X and y axis lie in the plane of the disk, but z axis is perpendicular to it. Z axis is perpendicular to it. Okay, right. By the theorem of perpendicular axis, you can write this one, no? That is what Iz is equal to Ix plus Iy. Iz is equal to Ix plus Iy, right? Remember one thing here, I will tell you, you know, x and y axis are along two diameters. X and y axis are along two diameters of the disk, and by symmetry, you know, by symmetry, that is what regular shape, right? Identical shape and identical equal parts. By symmetry, the moment of inertia of the disk is the same about any diameter, right? By symmetry, the moment of inertia of the disk is the same about any diameter. So that what can we write? Ix is equal to Iy. Ix is equal to Iy. When Ix is equal to Iy and substitute this value in this, then you can write like this, no? We can write like this, Iz is equal to 2 into Ix, right? When Iz is equal to 2 into Ix, you can write like this, no? Ix is equal to Iz by 2, that is equal to mr square by 4, and this value we know, that is what the moment of inertia of the disk about an axis perpendicular to it and pass through its center I is equal to mr square by 2. This value we know. So we are writing that value here, that is what mr square by 2, and already by 2 is there. So Ix is equal to mr square by 4. This is the moment of inertia of disk passing through any of its diameter, moment of inertia of the disk about any of its diameter and passing through its center. Passing through its center, that is mr square by 2, right? So here we understood how to calculate the moment of inertia of a disk about its diameter passing through the center by using perpendicular axis theorem. That is important. You know, now I have given disk. Next time I will give you any other. Suppose for example I will give you a solid cylinder. So you must know how to find the moment of inertia, and moreover how to use perpendicular axis theorem. That is important, right? That's why I told you perpendicular axis theorem, and that is what we are going to discuss in the next class, parallel axis theorem, right? So these two are important for us for competitive exams point of view, right? NEET and mains. Okay, right? Okay, it's clear. So in this class we discussed that is what perpendicular axis theorem, and then with one example we calculated moment of inertia of a moment of inertia of a disk about its diameter passing through the center, right? Now you see this table here, so this table is important for you, right? So actually we have to discuss this table in the previous class, but now why I am saying means, once if we get an idea how to calculate the moment of inertia at least for one object, then you may have a complete idea about how to write the moment of inertia for different shaped bodies, right? So that's why I didn't discuss in the last class, right? So now you can see this table, that is what moment of inertia of some regular shaped bodies about specific axis, okay, right? See this first, it is what serial number, and this is what body. So that is whether a circular ring or rod or disc or cylinder, whatever it may be, it is what body, and it is the axis. It is the axis based on what the body is going to rotate, and it is what figure, okay, and it is the moment of inertia. It is the moment of inertia I, okay, right. First, if you take a thin circular ring radius, of radius, okay, for example R, because here we are saying no. So thin circular ring of radius capital R, this is what thin circular ring, and it is going to rotate based on this axis. This is what perpendicular to plane at its center, this is what, okay. And here the moment of inertia is mr square. So when you are going to take a thin circular ring of radius capital R, there the moment of inertia is mr square for that is what circular ring about an axis which is perpendicular to the plane and passing through its center. Next, see here, thin circular ring of radius R, but here he changed the axis, that is what he changed the axis to diameter, right? So it is what diameter, and it is the center. So diameter passing through its center. So in this case the moment of inertia is mr square by 2, right? Here the moment of inertia is mr square by 2. And next, third one, he changed the body, that is rod, a thin rod of length capital L, okay, it is the rod So the length of the rod is capital L, and it is x axis, y axis and z axis. So here the axis what he is taking is perpendicular to the rod at midpoint, at its midpoint, right? And here the moment of inertia is ml square by 12, okay. And you can see how that is the rod is going to rotate, okay. Next, fourth one, here circular disc of radius capital R, right? It is what circular disc, circular disc means, how can you imagine? It is like a lunch plate, okay. So the lunch plate is there, no, circular shaped. So like that you have to imagine, but ending is not there. Ending is just like what is that? It's a flat circular disc. Radius is capital R, right? So when you are going to consider the moment of inertia when we are going to calculate the moment of inertia for a circular disc of radius capital R about a perpendicular to the disc and passing through its center, then it will be mr square by 2, okay, right. Next, it is what circular disc of radius R, but he changed the axis, that is what diameter. So regarding the diameter for the same object, but axis of rotation changed. So here axis of rotation is passing through the diameter. So here the thing is mr square by 4. So the moment of inertia is mr square by 4 for a circular disc of radius R about an axis passing through its diameter and center, right? Passing through its diameter and center. Otherwise you can take it as diameter itself, no problem. Next, hollow cylinder of radius capital R. Here axis of cylinder, that is what you can see here, see this picture, right? It is what axis of cylinder, right? So here if you are going to calculate the moment of inertia about an axis which is axis of which is the axis of this, see this I can show you axis of a cylinder, right? Here the thing is mr square is the moment of inertia, right? Next, solid cylinder solid cylinder of radius capital R, right? So here this is what here inside air is present, right, because it is a hollow cylinder. But here no air is present, it is completely material or matter, right? But we didn't change the axis of rotation, but mass changed, right? So it is hollow cylinder, it is solid cylinder. So you have to observe when I am giving these values, right? So it is not only the purpose to memorize. So this is the purpose, you have to understand the factors what I told you, based on the factors what I told you on which moment of inertia depends, that you can experience here, right? So if you take solid cylinder about the same axis as we discussed in case of hollow cylinder, the moment of inertia will become mr square by 2, mr square by 2, right? And last one, we are taking the solid sphere. You can imagine what is sphere, right? You just take short put, right? That is the best example of solid sphere. Radius is capital R. Radius is capital R. So in case of solid sphere of radius capital R, about its diameter, so this is the diameter. About its diameter, the moment of inertia will be 2 mr square by 5. 2 mr square by 5, right? As I told you, so this is the information about, for different objects, okay, different bodies, either different objects or different bodies, and about different axis of rotation. Here the body is same, but axis of rotation changed. Here the axis of rotation is same, but the body is changed. Like that I discussed to you, right? So 8 regular shaped bodies we discussed here. We discussed the moment of inertia of 8 regular shaped bodies about different axis of rotation. Okay. So in this class we discussed theorem of perpendicular axis, and after that we discussed one example problem, how to use the theorem of perpendicular axis to calculate moment of inertia about one particular axis what we want. Here it is purely application. It is purely application of theorem of perpendicular axis, that is Iz is equal to Ix plus Iy, right? After completion of that, we came here to discuss moment of inertia of some regular shaped bodies about specific axis, right? So my sincere request here is, I already told you, not only learning, right? We need to memorize because the derivations are not in our syllabus, right? So for basic objects, for basic bodies, right, we need to memorize. But while memorizing also, you have to get the logic behind that. So how it is possible to write the moment of inertia for different shaped bodies, right? For different shaped bodies, okay ma? Right. So in our next class, we will continue with next topic, that is theorem of parallel axis.